Hello everyone. Today we will talk about Unit 5, Decision Support Tools. Understanding Decision Support Systems. Decision Support Systems (DSS) are specialized information systems designed to assist individuals and organizations in making complex decisions. The primary aim of a DSS is to provide relevant data, analytical tools, and frameworks that enable users to interpret information effectively and arrive at sound decisions. These systems are particularly useful in scenarios where decision-making involves evaluating multiple alternatives or requires the assimilation of diverse data sources. Historically, the concept of DSS emerged as early as the 1960s and 1970s. During which time these systems were large, proprietary, and often prohibitively expensive. They were primarily used by corporate entities and organizations that could afford such sophisticated technology. Early DSS applications included tools that handled massive datasets, assisting users in making comparisons and forecasts, such as analyzing sales trends over extended periods. For instance, a typical early DSS might have included systems that process data from various departments to help executives make strategic decisions. In contrast, today's decision support tools are much more accessible and user-friendly. Spreadsheets, like Microsoft Excel, have become ubiquitous and provide a powerful means for users to manipulate and analyze data quickly. They allow individuals to compare data points, such as weekly sales figures, and can easily accommodate complex calculations and visualizations. Additionally, modern dashboard software summarizes vast amounts of information, presenting it visually to highlight trends and key performance indicators. These advancements enable decision makers to grasp insights at a glance, thereby streamlining the decision-making process. Furthermore, the evolution of communication tools has enhanced collaboration among decision-makers, allowing teams to work together effectively, even in remote settings. By utilizing shared data and insights derived from decision support tools, organizations can foster a more collective approach to decision-making. However, to leverage these modern systems successfully, individuals need a foundational understanding of spreadsheet applications. Basic spreadsheet knowledge is crucial for maximizing the functionality of DSS and ensuring that decisions are data-driven and objective. A DSS is ideal for analyzing complex problems that involve sets of data and demand a systematic decision-making approach. Decision support tools provide significant advantages for decision makers in various contexts. One of the primary benefits is that these tools add objectivity to the decision-making process. By requiring users to clearly define issues, identify relevant information, determine relationships between factors, and analyze results, decision support systems (DSS) facilitate a more structured approach. This objectivity allows decision makers to evaluate all aspects of a decision without bias. For instance, a company like Quest Specialty Travel can utilize graphical representations to analyze potential tour offerings for corporate clients, ensuring that decisions are based on factual data and comprehensive analysis rather than subjective opinions. Another key benefit is the improvement in efficiency when dealing with complex decisions. Complex decisions often require the gathering of extensive detailed information and necessitate the ranking or weighting of different factors. A computer can store vast amounts of information and perform complex calculations far more efficiently than individuals. By employing decision support software, organizations can manage, process, and report on the intricate details pertinent to their decisions. For example, Quest can evaluate the financial implications of opening a new branch office in either Los Angeles or Chicago, considering expenses like rent and travel, while weighing factors such as client proximity and local amenities. Additionally, decision support tools foster exploration and discovery. These tools allow users to visualize data, illustrate problems, and graphically represent various options and solutions. This capability enables decision makers to adjust variables and model different scenarios easily. For instance, Quest employees might use spreadsheets to compare current income and expenses with projected figures from establishing a new business travel department. This ability to simulate what-if scenarios encourages creative problem solving and can lead to innovative solutions. Furthermore, decision support tools provide essential support for specific decisions. Being part of an organization often necessitates justifying the decisions made. Intuitive or gut-based decisions can be challenging to defend, but an objective approach to analysis enables individuals to showcase their decision-making process professionally. A decision support tool may help compare various trip costs and volumes, aiding in the selection of the most cost-effective options. Finally, decision support tools enhance communication about decisions with stakeholders. Articulating the thought processes behind complex decisions can be daunting, but decision support models help visualize and clarify these processes. For instance, the steps involved in creating a new corporate travel department at Quest Specialty Travel can be depicted clearly using decision support tools, effectively communicating the rationale and methodology to interested parties. When tackling complex problems, it's crucial to gather comprehensive data that relates to the issue at hand. This systematic approach ensures that you have a solid foundation to analyze and understand the complexities involved in the decision-making process. By compiling all relevant data, you can create a well-rounded perspective of the situation, enabling you to make more informed decisions. Once you have gathered the necessary data, you can then model your decisions quantitatively. This involves representing decisions and their influencing factors using numerical data. For instance, if a company like Quest Specialty Travel is considering opening a new office, the decision-making process would involve listing projected expenses such as rent, utilities, staffing, and marketing costs, and comparing these figures to anticipated revenue from the new office. By quantifying both the costs and expected income, you create a framework that allows for direct comparisons and calculations. Modeling decisions in this way helps unveil patterns and relationships within the data. By analyzing these numerical representations, decision makers can identify trends, recognize potential risks, and assess the viability of different options more objectively. This leads to clearer insights, especially when weighing competing alternatives, allowing decision makers to evaluate which options align best with the organization's goals. Moreover, quantitative modeling provides a rational basis for decisions, offering substantiation that can be crucial when presenting choices to stakeholders. When decisions are backed by data and quantitative analysis, they become easier to defend and communicate. Stakeholders are more likely to trust well-supported decisions that are rooted in numerical evidence rather than subjective judgments. Guidelines for modeling decisions quantitatively. 1. Assign numeric values to your data. To begin the decision-making process, it's essential to gather measurable data that includes numeric variables. This can range from financial metrics such as price and sales figures to physical attributes like weight, temperature, square footage, and more. The accuracy of this information is paramount, so it is crucial to verify that the data collected is reliable. Once you have accurate data, enter it into a tool designed for numeric analysis, such as a spreadsheet. This sets the groundwork for a systematic analysis. To compare apples to apples. When collecting data, it's important to ensure that the information is presented in a consistent format. For example, if you're comparing salary data, you need to convert hourly or monthly wages to an annual salary, or vice versa. Similarly, adjustments may be necessary for different quantities. Temperature scales Celsius versus Fahrenheit, and currency dollars versus euros. By standardizing these variables, you can make valid comparisons between different data points and avoid misleading conclusions. 3. Rate subjective variables. In addition to objective data, subjective variables can also play a significant role in decision-making. For instance, you may want to gauge the preferences of Quest staff regarding potential locations for a new office. To integrate this subjective data into a quantitative model, you will need to assign numeric values to their responses. This can be achieved through a rating system, such as a 5-point scale, where respondents evaluate their preferences. This conversion allows you to incorporate qualitative opinions into your numerical analyses, creating a more comprehensive decision model. 4. Use a decision model. Once you have gathered and organized your data, the next step is to employ a decision model, which consists of formulas that incorporate all relevant variables and produce a calculated result. For example, if you are deciding between opening a branch office in Los Angeles or Chicago, you could create a model that rates factors such as staff preference, proximity to clients, and building features for each location. Additionally, you could calculate the total of associated costs, including monthly rent, taxes, utilities, and salaries. By computing the overall scores for each location based on these criteria, you can generate a ranked list of options, making the decision-making process clearer and more objective. Most people find it easier to comprehend images, concepts, and trends than to analyze large sets of numbers. This is because visual representations of data can simplify complex information and highlight key insights in a way that is more accessible and engaging. When presenting data to support a decision, it is crucial to convey the information objectively, ensuring that the audience can easily understand the context and implications. Using visuals, such as charts, graphs, and infographics, allows you to illustrate patterns and trends within the data without overwhelming your audience with raw numerical figures. For instance, a line graph might effectively demonstrate sales trends over time, enabling viewers to quickly grasp fluctuations and identify significant events that may have influenced those changes. Similarly, bar charts can be used to compare different categories, such as sales performance across different regions or products, making it easy to identify strengths and weaknesses. In addition to visuals, incorporating statistics can enhance your presentation by providing a clear framework for explaining and comparing characteristics of the data. Statistics can summarize complex information into meaningful metrics, such as averages, percentages, or variances, helping to contextualize the data. For example, stating that sales increased by 20% compared to last year can provide a more impactful understanding than simply presenting the sales figures for both years. Okay, now terms to describe data. 1. Mean. The arithmetic mean, commonly referred to as the average, is a fundamental descriptive statistic used to summarize a set of data. To calculate the mean, you sum all the values in the data set and then divide this total by the number of items counted. This single value represents the central tendency of the data, providing a quick snapshot of its overall level. However, while the mean is simple to compute and widely used, it can be influenced by extreme values outliers that may skew the result. 2. Median. The median is another measure of central tendency that identifies the middle point in a data set when arranged in order from lowest to highest. Unlike the mean, the median is less affected by outliers, making it a more reliable measure in cases where extreme values are present. To find the median, you line up all data points and select the middle one. If the data set contains an even number of values, the median is determined by averaging the two middle values. This characteristic makes the median particularly useful when dealing with skewed distributions. 3. Mode. The mode is the value that appears most frequently in a data set. Unlike the mean and median, the mode can be used to identify the most common data points, and there can be multiple modes within a single data set by modal or multimodal. This attribute makes the mode beneficial for understanding patterns, especially in categorical data. For instance, if tracking which weeks of the year most customers book tours, identifying the mode can help businesses optimize their marketing strategies by focusing on peak booking times. 4. Standard deviation. Standard deviation measures the variability or dispersion within a set of data points. A low standard deviation indicates that the data points are closely clustered around the mean, suggesting minimal variability. Conversely, a high standard deviation implies a wider range of values and greater variability. For example, consider two cities with the same average temperature of 75 degrees. One city might experience temperatures ranging from 95 during the day to 55 at night, while the other city has a narrow range of 78 to 72 degrees. Here, the standard deviation helps determine how much to advise clients on packing for different weather conditions, as a higher variability in temperatures would require different clothing than a more stable temperature range. When modeling a decision using quantitative data, mathematics plays a crucial role in analyzing and comparing various data points. Mathematicians and analysts often utilize formulas, which are precise mathematical expressions that outline specific calculations involving one or more variables. In the context of decision-making, these formulas are instrumental in manipulating data to derive meaningful insights, identify trends, and evaluate potential outcomes. Formulas serve as powerful tools for decision variables, allowing you to systematically explore and assess different options. For example, by applying formulas, you can calculate costs, project revenues, or analyze performance metrics based on various inputs. This structured approach transforms raw data into actionable insights, enabling you to identify the best choices and optimal solutions tailored to your specific objectives. To effectively model quantitative decisions, electronic spreadsheets, such as Microsoft Excel or Google Sheets, are often employed. These tools provide extensive support for a wide array of formulas and functions, making it easy to perform complex calculations without requiring advanced programming skills. With spreadsheets, users can input data, apply various mathematical operations, and create models that simulate different scenarios, facilitating clear comparisons between options. Additionally, Spreadsheets allow for dynamic analysis, where changes in input values can automatically trigger updates in the results. This feature is particularly beneficial for conducting what-if analyses, where you can adjust variables to see how those changes impact overall outcomes. Whether examining financial projections, evaluating resource allocation, or assessing risks, spreadsheets enable a comprehensive and flexible approach to decision modeling. OK. Guidelines for working with formulas and functions. 1. Format your formulas. When constructing formulas in a spreadsheet, it's essential to start with an equal sign equal. This indicates to the spreadsheet that a calculation follows. For example, instead of typing 2 plus 3 as you would on a calculator, you would enter equal 2 plus 3 in a spreadsheet cell. The equal sign is crucial because it signals that you want the spreadsheet to evaluate the expression, displaying the result in the selected cell. 2. Use cell references. While you can enter numbers directly into formulas, this approach can limit your flexibility. If a value changes, you'll need to edit each instance where that number appears in your formula. A more efficient method is to use cell references, which act as pointers to specific cells that contain your data. By organizing important decision variables as cell references like A1, B2, you can easily update values without having to rewrite your entire formula. This is especially useful for conducting what-if analyses, allowing you to see how changes in one variable affect the overall outcome. 3. Double-check your mathematical operators and order. Accuracy in mathematics is crucial, and even small typos or mistakes in formulas can lead to incorrect results. Research has shown that a significant number of spreadsheets contain errors due to issues with mathematical operators and the order of operations. Spreadsheets follow a specific order when calculating formulas, often PENDers, parentheses, exponents, multiplication and division, addition and subtraction. Therefore, it's important to review your formulas carefully to ensure proper mathematical operators are used and that the calculations are structured correctly. 4. Simplify with functions. Functions are pre-programmed formulas designed to simplify common mathematical tasks. Spreadsheet applications come equipped with a variety of functions that cover statistical, engineering, financial, and other calculations. To use a function, you start with an equal sign equal followed by the function name and its arguments, which are the values or cell references the function uses in its calculations, placed inside parentheses. For example, to manually sum a range of cells, you might write equal D1 plus D2 plus D3 plus D4 plus D5 plus D6. A more efficient way to achieve the same result is to use the sum function, equals sum D1, D6. The sum function automatically totals all the values in the specified range, simplifying the formula and making it easier to read and manage. When electronic spreadsheets were first introduced, one of their primary applications was in performing what-if analyses, often referred to as sensitivity analysis. This analytical approach provides a way to explore how changes in specific input values can impact overall results. By adjusting one or more variables, decision-makers can evaluate different scenarios and outcomes, which is crucial for informed decision-making. What-if analysis enables users to test various possibilities, simulating different conditions and their effects on a given situation. For example, if a business is deciding on a pricing strategy, it can use what-if analysis to see how different price points might affect sales volume and overall revenue. By modifying the values of key inputs, such as costs, prices, or customer demand, analysts can observe how these changes alter the financial projections or other relevant metrics. This technique is particularly valuable because it allows for the identification of potential risks and opportunities. By understanding how sensitive outcomes are to changes in inputs, organizations can prepare for different scenarios, thereby improving their strategic planning and responsiveness to market fluctuations. 1. Identify decision variables. The first step in a what-if analysis is to pinpoint the decision variables that can change and thus influence the results of your analysis. Statisticians often refer to these as independent variables. To determine if a value is a decision variable, consider whether adjusting it would alter the outcomes of your analysis. For instance, in a business context, decision variables might include factors like pricing, number of trips, or customer demand. Each of these can directly impact the results you're examining. 2. Identify the constants. Next, identify the constants, elements that remain relatively stable over time and do not vary in your analysis. Constants are crucial as they provide a stable backdrop against which the effects of changing decision variables can be measured. For example, if Quest's specialty travel is estimating revenue from 3 types of business trips, the price of each trip, like a discount trip priced at $1,200, acts as a constant. This value will remain unchanged regardless of shifts in other variables in the spreadsheet. 3. Identify output variables. Output variables are the results that may change in response to modifications in the decision variables. Known as dependent variables, their values hinge on the independent variables you've defined. These outputs are the core focus of your analysis, as they reveal the effects of your decision-making. For example, if Quest determines that it can generate about $716,000 from business trips over 6 months, this revenue figure would serve as an output variable influenced by pricing strategies and the number of trips offered. 4. Test several scenarios. In a robust what-if analysis, it's important to evaluate multiple scenarios. For each scenario, consider a variety of potential values for each decision variable and input these values into the spreadsheet. By observing how these variations affect your output variables, you enrich your understanding of the situation. For instance, Quest's specialty travel might analyze 2 different pricing strategies, one for discount trips and another for premium offerings, to see how each impacts overall revenue. 5. Assess your results using common sense. Finally, it's critical to assess the results of your analysis with a discerning eye. Thoroughly review your spreadsheet for any errors or flawed assumptions that might distort your findings. Utilizing simple test data can help verify that the results align with your expectations. If the outcomes appear unreasonable or overly optimistic, recalibrate your analysis by hand to catch potential mistakes. Additionally, seeking input from trusted colleagues can provide valuable perspectives and help ensure that your analysis is both accurate and realistic. When making decisions that involve multiple influencing factors, it can be beneficial to assign weights to the variables in your decision model. This approach acknowledges that not all variables have the same impact on the outcome, allowing for a more nuanced analysis. Weighting variables involves quantifying their relative importance in the decision-making process. For instance, when Quest Specialty Travel is considering which tours to offer to corporate customers, several factors come into play, such as travel time, level of activity, meeting facilities, and weather conditions. By assigning weights, Quest can prioritize these variables based on their significance to customer preferences and overall satisfaction. For example, Quest determines that the amount of travel time significantly influences customer decisions, warranting a weight of 50%. This reflects a strong preference for shorter travel times, indicating that reducing this factor could lead to higher customer satisfaction. Conversely, meeting facilities are deemed less critical, receiving only a 10% weight. This indicates that while meeting facilities are important, they do not carry as much influence as travel time in the decision-making process. Okay, now guidelines for weighing factors. 1. Identify the most important decision variables. The first step in refining your decision-making process is to identify the most important decision variables, those that are likely to have a significant impact on your output variables. When faced with numerous independent variables, it's wise to focus on a select few that will really influence the decision at hand. For instance, if a company like Quest Specialty Travel is evaluating tours for corporate customers, 4 relevant variables might include activity level, meeting facilities, travel time, and weather. By concentrating on the most critical factors, you streamline your analysis and enhance its effectiveness. 2. Determine the appropriate weights. Once you've identified the key variables, the next step is to assign appropriate weights to each one. Weights are numerical values that reflect the relative importance of each variable in relation to the decision being made. For example, if travel time is deemed the most crucial factor, it might receive a weight of 50. The next priorities, activity level and weather, could each have a weight of 20, while meeting facilities might be assigned a weight of 10. Calculating weighted ratings involves multiplying each rating by its corresponding weight, allowing you to total the weighted ratings for each alternative. This helps identify the best option based on a structured, quantitative approach. 3. Normalize variables. Normalization is essential when dealing with decision variables that have varying ranges. For example, if Quest is comparing 5 local tour operators in the Caribbean, the most expensive option might cost $50 per person, while the least expensive costs $10. This wide disparity in pricing could skew comparisons if not addressed. To normalize the price variable, you can divide each price by the highest price in that range, ensuring that the values become consistent and comparable. By using these normalized variables as weighted factors, you can incorporate them more effectively into your overall analysis. 4. Consider the runners-up. Recognizing that the weights you assign are somewhat subjective is important for a well-rounded decision-making process. As you evaluate the analysis results, consider whether small adjustments to these weights might change the outcome significantly. Examine the alternatives that come in as runners-up, options that scored just below the leading choice. Understanding how close these options are to the top rating can reveal additional important decision variables. This examination encourages a broader perspective, as closely ranked alternatives often merit further consideration, ensuring that you're not overlooking potentially valuable options. A decision tree is a powerful support tool designed to aid in the rational selection of the best option among several alternatives. This model is visually represented as a tree-like diagram, where each branch signifies a distinct option along with its associated benefits, costs, and probabilities of occurrence. By utilizing a decision tree, organizations can systematically evaluate their choices and identify the strategy most likely to lead to their desired goals. Structure and functionality. Each node in a decision tree represents a decision point or chance event, branching out into various possible outcomes. For instance, if a company is deciding whether to launch a new product, the initial branch might delineate options such as launch or do not launch. Subsequent branches could represent potential benefits like expected revenue from the launch and costs like marketing expenses, as well as the likelihood of success for each path. This structured approach allows decision makers to visually track the consequences of their choices and weigh the potential impact of different scenarios. Benefits of using decision trees. The graphical nature of decision trees offers several advantages. Firstly, they simplify complex decisions, transforming intricate variables and outcomes into a clear visual format. This clarity is particularly valuable for discussions with stakeholders, as the diagram provides an accessible summary of the decision framework. Additionally, decision trees facilitate exploration of possibilities, encouraging teams to consider various outcomes and the relationships between different options. Creating a decision tree. Building a decision tree can be done manually on paper or by utilizing basic graphic design software on a computer. The process typically involves identifying the primary decision to be made, mapping out the possible options and their potential outcomes, assigning values to each option based on benefits, costs, and probabilities, analyzing the branches to determine the most advantageous path. Okay. Now, guidelines for creating a decision tree. 1. Start with your primary decision. Begin your decision-making process by clearly defining the primary decision to make or problem to solve. This will serve as your goal. For instance, if your objective is to identify a new adventure tour destination in Latin America, create a small box on the left side of your paper or screen. Label this box with a brief description of your primary objective, such as select adventure tour destination. 2. Identify your options. Next, delineate the various options available for your decision. In this example, you might consider destinations like Cusco in Peru, Quito in Ecuador, or the option of choosing neither. Draw a line extending from the objective box to the right for each option, ensuring the lines are spaced apart for clarity. Label each line with a concise description of the option, such as Cusco or Quito. 3. Consider the results. At the end of each option line, indicate the potential results. If a result for choosing that option is uncertain, draw a small circle. If it leads to another decision, draw a small square. This process continues from each decision square, creating branches that represent all possible outcomes. For instance, if you choose Cusco, you may branch out to additional outcomes like successful tour or low participation. 4. Assign values and probabilities. Next, estimate the value each option holds for your organization. This could be a monetary figure, such as projected revenue, or a score based on a 1 to 5 rating scale. For example, you might assign $730,000 in revenue to the Cusco tour and $670,000 to the Quito tour, labeling the outcomes with these amounts. For each uncertainty node represented by circles, estimate the probability of each outcome occurring. Ensure that the total probability for each circle sums to 100%. This step is crucial for accurately assessing risks and potential rewards associated with each option. 5. Calculate the value for each option. To finalize your decision tree analysis, calculate the overall value associated with each possible outcome. Start on the right side of your tree and work your way back to the left. For instance, if the Cusco tour has a 70% chance of generating $730,000 and a 30% chance of generating $0, you would calculate the expected value as follows. Expected value Cusco equals 0.70 multiplied 730,000 plus 0.30 multiplied 0 equal 511,000. Repeat this calculation for each option, summarizing the expected values to compare and identify the most advantageous choice. Representing data, decisions, and solutions graphically can significantly enhance your ability to identify trends, relationships, and outcomes that might be obscured in a numerical format. Visual aids such as drawings, charts, and various illustrations simplify complex information, making it more accessible and comprehensible. This approach not only aids understanding, but also helps in convincing stakeholders of your conclusions and recommendations. One of the primary benefits of graphical representation is clarity. Visual tools allow viewers to quickly grasp intricate data sets. For instance, a line graph displaying sales trends over time can reveal patterns that a table of raw numbers simply cannot. In addition to clarity, graphical representations facilitate the identification of trends and fluctuations, such as seasonal changes in sales or evolving customer preferences. By visualizing this data, organizations can make proactive adjustments to their strategies based on the insights gained. Another advantage is the ability to explore relationships between variables. Charts such as scatter plots effectively illustrate correlations, helping analysts assess the effectiveness of marketing strategies by displaying the relationship between advertising expenditure and sales revenue. Additionally, visual aids enhance communication, allowing for clearer expressions of ideas and results to stakeholders. A well-designed presentation slide that incorporates relevant charts can convey key messages far more effectively than lengthy explanations. Engagement and persuasion are also vital aspects of visual representation. Graphical displays can increase audience engagement during presentations, making your arguments more compelling. They allow the audience to visualize data and understand its implications, often leading to better decision-making. To create these visual representations, various software tools are available, such as spreadsheets like Microsoft Excel and Google Sheets, which facilitate the creation of charts and graphs from data sets. Presentation graphics programs like Microsoft PowerPoint and Google Slides enable the incorporation of visual elements into presentations, enhancing the storytelling aspect. Popular types of graphics that display data. 1. Bar charts. A bar chart is a visual representation that uses rectangular bars to display data values. The length of each bar corresponds to its value, with longer bars indicating greater values. Bar charts can be arranged either horizontally or vertically. Simple bar charts typically utilize one set of bars to represent a single variable or a specific point in time. However, they can also showcase multiple variables or points in time by displaying several adjacent bars, allowing for easy comparison across different categories or time periods. 2. Line charts. Line charts are another effective tool for visualizing data, particularly for tracking trends over time. To create a line chart, you plot a series of data points and connect them with a line. Each point on the chart represents a specific measurement or value, and the connecting line illustrates the direction of change, making it easy to identify trends, patterns, or fluctuations in the data over a defined period. 3. Area charts. Area charts share similarities with line charts, but offer a distinct way to represent multiple variables over time. They display the values of each variable as cumulative totals using either numbers or percentages, layering the variables on top of one another. This layering creates a visually appealing effect that allows viewers to see not only the individual contributions of each variable, but also their overall impact. Colors or fill patterns are often used to differentiate between the variables, enhancing clarity and comprehension. 4. Pie charts. Pie charts visually depict data through circles divided into sectors, where each sector resembles a slice of pie. The size of each slice represents the relative size or frequency of the corresponding variable. Since the entire chart forms a complete circle, pie charts effectively illustrate the percentage that each variable contributes to the whole. They are most easily interpreted when the largest slice comprises at least 25 to 30% of the data. Ideally, pie charts should focus on emphasizing a single variable, facilitating comparison with the other slices in the context of the total. 5. Scatter plots. Scatter plots are useful for illustrating the relationship between two variables within a dataset. In a scatter plot, one variable is represented along the horizontal axis, while another is plotted on the vertical axis. This visualization allows for the examination of correlations between the variables, particularly non-linear ones. If the points in the scatter plot appear random and unordered, it suggests that the two variables do not exhibit a strong relationship. Conversely, if the points cluster together in a discernible pattern, it indicates some level of correlation, which can be further analyzed. Spreadsheet software, such as Microsoft Office Excel, OpenOffice Calc, and Google Sheets, serves as a powerful tool for creating and formatting numeric data. These applications are widely utilized for a variety of tasks, including budgets, commission calculators, schedules, and income statements. The versatility of spreadsheets makes them indispensable in both personal and professional settings, allowing users to efficiently track and analyze numeric information. One of the primary advantages of electronic spreadsheets is their ability to perform complex calculations. Users can input formulas that automatically calculate totals, averages, and other metrics, ensuring accuracy and efficiency in data handling. Additionally, spreadsheets are invaluable for conducting what-if analyses, enabling users to explore different scenarios by changing input values and observing how these adjustments impact overall outcomes. This capability is particularly useful in financial planning and analysis, where adjustments in projections have immediate effects on related calculations. A standout feature of spreadsheet software is its dynamic updating function. When a value in one cell is modified, all related calculations across the spreadsheet automatically refresh to reflect the change. This interconnectivity allows for seamless adjustments and real-time data analysis, which is crucial in financial environments where up-to-date information is vital for decision-making. Among various spreadsheet applications, Microsoft Excel remains the most popular choice for Windows and Macintosh computers, a position it has held since 1993. Its robust features, user-friendly interface, and extensive capabilities make it a favorite among individuals and organizations alike. Features such as advanced functions, data visualization tools, and collaboration options further enhance Excel's appeal, supporting a wide range of users in their data management tasks. Types of spreadsheet software. 1. Microsoft Office Excel. Microsoft Excel is a key component of the Microsoft Office suite and is widely adopted across business, education, and research environments. Its popularity stems from its versatility, allowing users to create everything from basic spreadsheets to sophisticated, multi-sheet workbooks that support complex business decision-making. Excel offers a robust set of features, including advanced formulas, data visualization tools, and extensive formatting options, making it the dominant choice in the personal spreadsheet market. 2. Google Spreadsheets. Google Spreadsheets, part of the Google Workspace suite, is a straightforward tool for creating and editing spreadsheets online. While it provides basic importing and editing features and is more limited in terms of formatting compared to Excel, its strength lies in its emphasis on collaboration and sharing. Users can easily work together in real time, making it an ideal choice for teams and projects that require collective input and accessibility from multiple devices. 3. OpenOffice Calc. OpenOffice Calc is a free and open-source spreadsheet program modeled after Microsoft Excel. Available for download from the OpenOffice website, it caters to users looking for a capable spreadsheet tool without the associated costs. Calc can open and save files in the XLS format Excel 2003, ensuring compatibility with Excel users. Notably, it has features such as series definition for creating charts based on data layout and the ability to save spreadsheets as PDF files, enhancing its utility for sharing and presenting information. 4. Numeric. Numeric is another free, open-source spreadsheet program designed specifically for the Linux operating system as part of the GNOME desktop environment. While it aims to replicate many functionalities of Excel, it lacks some advanced features like conditional formatting and pivot tables. However, it is regarded as a reliable tool for professionals engaged in statistical analysis, providing necessary functions and a straightforward interface that suits those focused on performance rather than extensive formatting options. 5. Apple Numbers. For Macintosh users, Apple Numbers offers a user-friendly alternative as part of the iWork suite. Numbers emphasizes ease of use and facilitates the creation of visually appealing charts and tables. While it excels in design and presentation, it does not include some of the advanced features found in Excel, such as pivot tables and Visual Basic for applications VBA for automation and customization. This makes it best suited for users who prioritize aesthetics and simplicity over deeper functional capabilities.
Thank you for watching. If you liked this video, please like and subscribe to channel.